Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. I decided to make my broadcast a little bit more interesting. Hey, you know what? We're all learning from home now. I thought it might be a little bit better just to have a little bit more familiar stuff. So I got my classroom. They let me in my classroom for about 10 minutes the other day. And one of the things I did was just snag a picture. So, I mean, I know if you guys are actually in class, those of you who actually do sit in this back corner, there'd be students in front of you and stuff. But hey, you know what? I decided to try and make it work out or make it look a little bit better. I apologize. I got some weird like graphical strobing stuff. Now, whenever I actually point this out, you're going to be able to like, notice it a whole lot more. But watch this. Let me see. The reason that's happening is because of I'm having some issues in my little home studio here. It's a lighting issue, is what it is. Here's my green screen behind me, and you can see that it's like lighter down here and darker up here. It's just having a little bit of problems cutting that out, and because of the color differences. I mean, yeah, it's not a professional studio at all. It's literally a green sheet hung on the wall. But hey, now that I say that, you can see that really bad now. But anyway, just having a little bit of fun. And let's go ahead and get our lesson up here on the board, zoom in on it. And wow, now that I say that, that's really bad. Oh well. All right, so lesson 10-3, chords. Let's get this done pretty quick. Now, remember, a chord is any time that a segment cuts across a circle and intersects the circle 2 times. A diameter is a special case of a chord. So anytime that two chords are congruent, so if FG is congruent to JH, then the corresponding arcs are also congruent. So arc FG is congruent to arc JH. And it works the other direction as well. If the arcs are congruent, then their corresponding chords are congruent as well. So let's see. It tells me that in circle K, the two arcs, AB and CD, are congruent to each other, which we have marked with those single lines, or single hash marks. So we want to find the measure of AB, or the length from A to B. Well, since the two arcs are congruent, then the two chords are also congruent as well. So I can set them equal. 2x plus 3 is equal to 8x. Now, we're just going to go through and do our solving steps. Subtract 2x from both sides, leaves me 6x on the right. Divide both sides by 6, gives me x equals 3 divided by 6, or 1/2. Now, to find the measure of AB, I'm just going to, where's our parenthesis there? Plug in 8 times 1/2, which is 4. So AB equals 4. Remember, congruent arcs means that the chords are congruent, set them equal, and solve. All right, example 2. Now, since I know that my two chords are congruent, then the arcs are congruent as well. So since this guy over here is x, arc RS is x, then arc ST is also x degrees as well. Now, if I just set x equals x, that's not going to help me very much, but I do know that the full circle all the way around is 360 degrees. So I can set up the equation x plus 64 equals 360 degrees. So that gives me 2x, and I'm going to go ahead and subtract the 64 on both sides. 360 minus 64 is 296. Now we're going to divide both sides by 2, and x equals, oh man, you know what? My pre-AP kids were razzing me the other day because I couldn't do this in my head. 296 divided by 2 is 100. 96 divided by 2 is going to be, you know what? Forget it. I'm just going to do it the long way. I don't have a calculator in front of me. 1, 2 minus gives me 96. So that's a 4 minus 8, 1, 6, 148. There we go. X is 148. Hey, if you've got a calculator, hit the button. I just don't have the calculator. All right. Sorry, it's taking a while for this to load up. Okay, now it tells me that circle M is congruent to circle P. Now, whenever I have two circles that are congruent, that means they've got equal radii, equal circumferences, corresponding arc or congruent arcs in each circle means they're also going to have congruent chords in those circles. So since I've got that this arc is congruent to that arc, then the chords, the corresponding chords are congruent as well. So 6x equals 2x plus 24. 6x minus 2x gives me 4x equals 24. Divided by 4, 24 divided by 4 is 6. Easy enough. Okay, now this thing looks confusing at first. Here's what I want to make sure you don't get caught up on. Do not get caught up on the idea that from W all the way down to Z is a diameter. Okay, they could be going off at different angles. I mean, for example, it could have been something like that, and all these properties would still apply. So don't get caught up on the idea that WZ is a diameter. Okay, so if I have two chords, a diameter that is perpendicular to a chord. So here we go. AB is a chord, and then WO is perpendicular to it. So a chord with a perpendicular radius or diameter. Then that chord has been cut exactly in half. It is bisected. AX equals AB. Okay, so if I got the radius that's perpendicular, those two are equal. All right, now it also, because of that, means it's going to cut the chord into equal pieces as well. Okay, now the exact opposite of that applies as well. If I have a chord, it has a perpendicular bisector. So if I've got a chord and then I've got a perpendicular bisector, then I know that thing WO is a radius or diameter. Means it will go exactly through the center of the circle. Okay. Also, if I've got two chords are congruent if and only if they are equidistant. So here's what we got. AB and RZ are equal to each other only if XO and OY are congruent. Only if their distances from the center are the same. That works the other way around as well. If XO equals OY, then AB equals RS. Okay. That's a lot. Basically, these two pieces are all of these are equal to all these, and that is also cuts everything in half. Not my best picture in the world. Let's see how that actually pans out. Okay. In circle G, arc DEF is 150. Find arc DE. Well, since I have a radius here that is perpendicular to the chord, then that means that the chord has been cut in half and the arc has been cut in half. So if this entire thing is 150 degrees, then DE is going to be exactly half of that, or just 150 divided by 2, which is 75 degrees. Because each half has to be equal, cut it in half. Okay, we know that EF equals GH equals 24. So EF is this thing is 24. GF is also 24. We want to find the distance from P to Q. Okay, the two chords are equal only if they are the same distance from the center. So what that means is that QP must equal PR. Set them equal, and then we can solve from there. So 4x minus 3 equals 2x plus 3. We're going to then subtract 2x on both sides. 4x minus 2x is 2x. Add 3 on both sides, and that's going to give me add 3, so equals 6. Divide by 2 gives me x equals 3. Now, we're not done. We need to know the distance from P to Q. So PQ is 4 times x, which is 3, minus 3. 4 times 3 is 12, minus 3 is 9. I know that was fast. Good thing about YouTube, you got the pause button. Go back, rewatch if you need to. Important thing there, the two chords are equal. Therefore, the distance from the center to the chords are equal as well. All right, circle A, the diameter is 12. So from B all the way to E is 12. CD all the way here is 8. So this whole distance is 8. Find AF. So I want to know just the distance from different thing here, just AF. Okay, here's what we need to know first. Because the diameter is perpendicular to CD, that means that CD has been cut in half. So this equals this, and if the whole distance from C to D is 8, then each of those is 4. So I'm going to go ahead and mark that in on just one of them. This piece is 4. Now, the diameter is 12. If the diameter is 12, then the radius is half of that, which is 6. So here's what I'm going to do to make this work out. I am going to draw another radius from A to C. Now, I can draw any radius I want in the circle. Every single one of them is going to have the same distance. In this case, the distance is 6. So now I can do the Pythagorean Theorem to find this distance I've listed in pink here from A to F. That's going to be my B value. So Pythagorean Theorem, A squared is 4 squared plus B squared equals C squared, which is 6 squared. So B squared, 16 plus B squared equals 36. Subtract on both sides. B squared equals 20. And then take the square root. B equals the square root of 20. And now, there's no way I'm doing that in my head. Let me go find it somewhere. Hey, you know what? Where's my calculator app? Not the best in the world, but we can make it work. Come on, here we go. 20, and then square root of 20 is 4.47. 4.47. So there we go. That's all we got. Yep, that's my last example. Short and sweet. Like I said, feel free to go back and re-watch those. Nothing really too difficult in this assignment. So I'll let you guys get back to it. Short and sweet, only 13 minutes. Stay safe, stay healthy, and always stay patriotic.